Okay, we are going to continue on with 813 day 2. So I'm on problem 48 of the note sheet that you would have printed yesterday. And we're going to continue looking at how to find the exact stretch factor or leading coefficient for a polynomial function. So we're back to the county fair coaster ride, and it says, now that you have more expertise with polynomial equations and their graphs, the Math America Land Carnival Company has hired your team to find the exact equation to represent the roller coaster. Okay, now if we look at our roller coaster, it says the numbers along the x-axis are in hundreds of feet. So we see that at this point right here, at x equals 2, that really represents 200, for instance. Okay, but we are zeroing in at 250 feet. So where's that going to be? That is going to be in between the 2 and the 3. So at 250 feet, the track is 20 feet below the surface. So that means that using the scale that was set for us, okay, the point 2.5, negative 0.2 represents the point that they are describing that I've drawn an arrow to, okay? So we're going to answer a few questions about this graph. So first of all, what degree polynomial represents the portion of the coaster that we are seeing? Okay, so if we just assume that we have arrows going up right away because we see up, up as our end behavior, okay, we know that is going to automatically be an even degree, okay, because of the same end behavior. Okay, so if we look, we see that on the x-axis, we have an x-intercept that is going through the x-axis. We have an x-intercept at 2, which is bouncing off, so we know that has to be a what? An even degree of that factor. And then we have just another x-intercept where the graph is crossing. So we are going to say that there is going to be a minimum degree of 4, okay, because we are going to have these two factors just be repeated once, and then this has to have an even power attached to its factor because it's bouncing off of that x-axis, okay? So we know that what is the equation going to look like? Well, let's first start with what are the roots, okay? What's another word for roots? Another word for roots are x-intercepts. Okay, so what are the x-intercepts? The x-intercepts are, you can look at my arrows, 0, 2, and 3. Okay, but those aren't the factors. So if we want to put that into an equation, we learned yesterday that we don't want to just jump to thinking that the leading coefficient, the stretch factor, is 1. So we want to consider that there might be a stretch factor, but then we are going to use these x-intercepts for our factors. So we have, when x is 0, that factor is going to be what? It's just going to be x, okay? And because it slices the x-axis, that occurs once. But then at x equaling 2, that's going to be x minus 2. It has to have an even power. So we're going to start with the power of 2. And then at x equaling positive 3, we have x minus 3. So now we have to figure out what is our A. So in order to do this, okay, what do we have to do? We learned this at the end of the lesson yesterday. Okay, we learned that we are going to plug in a given point. And so at that, the given point is 2.5, negative 0.2. And then we're going to solve for A. So we have negative 0.2 equals A times 2.5 times 2.5 minus 2, quantity squared, times 2.5 minus 3. Don't close the parentheses until the end. Okay, so when we go ahead and do this, we're going to look at negative 0.2 equals A times 2.5 times 2.5 minus 2 is 0.5. And then 2.5 minus 3 is negative 0.5. Okay, so then when we go ahead and do the multiplication, we get negative 0.2 equals and we take 2.5 times 0.5 times negative 0.5, and we get negative 0.3125. And what's attached to that? An a. Okay, so now in order to solve for a, we divide both sides by negative 0.3125. And when we do that, we end up getting that a equals 0.64. Okay, now notice I want to try to round as minimal as possible. So this, I went out to the nearest, the 10,000th place. Okay, so with that being said, we now have the equation. Okay, so our a is going to be replaced with 0.64. So we have y equals 0.64 times 0.64x times x minus 2 quantity squared times x minus 3. So there is the exact equation of the coaster that they were wanting us to look at. Okay, so now let's see here. We are being asked to find the minimum or the deepest part of the coaster's tunnel. Okay, and this is just kind of making sure that we are up to date on our equations, and we want to look at the graph for this one. If we're looking for the deepest point, this is really saying what is the minimum of the graph. Okay, well, the minimum is going to occur at the depth of the valley or at the bottom of the valley. So we see that that is going to be right here. Well, it's really nice because we can note that the depth or the bottom part of the coaster is occurring at what? X equals 0.5. So we are going to want to evaluate now our equation that we have and look at x equaling 0.5. So you're going to plug that in for x and carefully do the calculation. Okay, so you can actually plug this all in one step if you do it correctly. And sorry, I hadn't done this beforehand. Shame on me. So 0.64 times 0.5 times 0.5 minus 2, close the parenthesis and square it. And then parenthesis 0.5 minus 3. And we get negative 1.8. So when x is 0.5, y equals negative 1.8, but what does that correspond to? Remember, it goes up, or every 1 unit really represents hundreds of feet. So this represents 180 feet. Is the deepest point of the roller coaster. So we have 180 feet is the deepest point because you would multiply 1.8 times 100 and the negative means it's below ground. Okay, so a nice kind of story problem to get us warmed up. So we see that some polynomials have a stretch factor, just like a in parabolas and other parent functions. We also looked at kind of a value of a for our trigonometric functions in Chapter 7. So what I'd like you to do is pause me and write an exact equation, including the stretch factor for each graph below, and then check your response with me after. All right, so if we look at this graph, it looks like we have a bounce going on at -2, and then we're just slicing the x-axis at 2. So when I'm thinking about my equation, and I also know it's going to be odd degree because of my opposite arrows, I notice, okay, we can write that we're odd. Also, we are negative in orientation because the up arrow comes first, which is opposite of the cubic parent function. So when I write my first equation, y equals a, I don't want to just put a, I want to put negative a. Okay, and then from there, I am going to, let me think for a second. This is what we ran into with our parabolas as well. Let's start off with an a and kind of see what we get from there. So let's say you didn't catch that it was negative in orientation. So we have our a, and then we said the factor x plus 2, because it's the opposite of negative 2, is going to bounce, so it has to be at least squared. And then we're going to have x minus 2 occurring once. Okay, so now I want to use my lattice point which is at 0, 16, and solve for a. So I have 16 equals a times 0 plus 2 quantity squared times 0 minus 2. So I get 16 equals a, and then 2 squared is 4. 4 times negative 2 is negative 8. Okay, so from here, then I'm going to go ahead and divide both sides by negative 8, and I'm going to get that a equals negative 2. All right, so as I said up here, the systematic process takes care of the negative for us, which is very, very nice. So what is my final equation? My final equation is y equals negative 2 times x plus 2 squared times x minus 2. That is the final answer that we want. Okay, now on this next one, if I look and do an analysis quickly, I know, not odd, I know it's like a parabola in its end behavior, so it's even degree. And then we also know it's going to be negative in orientation because it's opening down like a frown rather than our normal parabola that opens up. When I look at my x-intercepts, I see that both are bouncing off the x-axis. So I'm going to have two factors that are going to be at least a double root. So I have y equaling a. I can ignore the negative. It'll take care of it when I put in my, my point on the graph. And I have, let's see, x, the opposite of negative 2 is positive 2 squared. And then I have x minus 2 squared. Okay, so to solve for a, I want to also see that I have a nice y-intercept again, and it looks like the y-intercept is at negative 3, so I am looking at the point 0, negative 3. So I have negative 3 equals a times 0 plus 2 squared, and then times x minus 2 squared. So then when I do the math, I have negative 3 equals a, and then 4 times negative 2 squared is 4, so 4 times 4 is 16. My bad. Hopefully you're screaming at me right now. I knew something wasn't working out. Okay, we need to go back up and see that I misread the graph. Okay, the second x-intercept is at 1, not 2. So it should be x minus 1 squared, and then we're going to have 0 minus 1 squared. So when I do 2 squared is 4, negative 1 squared is 1, so 4 times 1 is 4. So I have my 4 here. Okay, and then I can go ahead and divide by 4, so my a value is negative 3/4. So that's the stretch factor. So it was actually compressed because when our number is less than 1, it's going to be kind of pressed downward. So I want to stress the importance that you cannot use an x-intercept as the point that you plug in. Okay, so do not ever use these x-intercepts as the point that you plug in to find your value of a. So our final equation is y equals negative 3/4 times x plus 2 quantity squared times x minus 2 quantity squared. Okay, there we go. So now we are going to move on to a few more cases that might pop up, and then we'll conclude 813, sorry. So again, pause me and try it. It says write a polynomial equation for a function of a graph that bounces off the x-axis at -1, 0. So we know right away that it's going to be at least a double root because that factor has to be even powered if it bounces. And also it's going to slice through at 4, 0. So that factor is just going to be raised to the first power. And then it has to go through this point, which is not an x-intercept. So we are going to use that point to find a. So if we write our initial equation, we have y equals a. And then we are going to use our root of -1 to write x plus 1. And we are going to square that because it bounces. And then we have x minus 4. Opposite of 4 is -4. And now we're going to find a by inputting -18 for y and -2 for x. Okay, so -18 equals a, and then we have -1 squared is 1, -6. So we have -18 equals a times -6. So then we have divide by -6, a equals +3. Okay, so we have our equation, which is going to be y equals 3 times x plus 1. Quantity squared, and then we have x minus 4. So there is our equation. But now, of course, here comes the curveball. It says Armando came up with the equation 3 times the quantity x plus 1 to the 4th times x minus 4. Okay, does the equation fit all of the given criteria? Why or why not? Is it the same equation you came up with? Well, right away, is it the same equation we came up with? The answer is no. Okay, but let's go ahead and check the point that we just used, which was -218, because it has to satisfy that given point in order to match the same graph that we were using. So when I ask, is -18 equal to 3 times -2 plus 1 to the 4th, and then -2 minus 4, what do we notice happens? Okay, when we simplify, we have -18, does that equal 3 times, once again, we have -1, which we had up here, being raised not to the second power, but to the 4th power. Now, what's -1 times -1? It's 1, but then what if I take times -1 times -1? It still is going to be 1. Okay, so this seems like it might lead us to kind of some false impressions about finding the one and only one equation. Okay, so if I finish this all the way through, I would get, yes, -18 equals -18. So the issue here, the reason we're raising this problem, is that this equation and the equation we got up here both have the point -2, -18 in common. Okay, so how are we going to figure out which equation we really wanted or we were really looking at? So it says, okay, well, the key or the reason that we're doing this problem is that we would then need to test another point. So when we see that when we basically have -1 or +1 in the parentheses being raised to an even power, we've got to be careful, okay? So when you have, let's see, when a factor becomes 1 or -1 after you do the math inside the parentheses. Okay, so now if we would go ahead and use this point here, and if we would test in number 50, we see that it does not work. But if we test it in number 51, which is right above, it works. So the moral of the story is really, if they would have given us this additional information, which they didn't, but if they did, then everyone would be expected to get this answer, which is not necessarily the first answer that pops into our head, because when we hear bounces, we always use 2. We always start low and then decide if we need to go high. So this is still an even power, but it's not the power that we try first. All right. So our final question is basically saying, what information about the graph of a polynomial function is necessary to determine exactly one correct equation? Okay. Well, we would need to be told how many times a repeated factor occurs. Okay, so if you're telling me that it bounces, we know that bounces means that it could be raised to the second power. We know that it could also mean the fourth power. We need to know, okay? So we need some information there. Okay, the other option, if they don't want to tell us that, or they need to give additional point to check with. Okay, so basically they need to give us 2 non-x-intercepts. Okay, and this is only going to happen, let me stress, when you have repeated factors. So if everything is just raised to the first power, if there's no bouncing or leveling off, then this is not going to be an issue. Okay, so obviously this last page was maybe kind of a little beyond what I would expect at this point. But you need to be exposed to seeing these special cases and kind of know that everything doesn't just work out nice and pretty as we would like it to. Okay, so that concludes 813. Make sure to finish up the 813 homework, and we'll move on to the next section on the next lesson.